GM everyone. Welcome to the fifth session of Cairo Bootcamp 2, organized by Blockfuse Labs. And we have come thus far. I could remember leaving everyone here on the first call where we were introducing you guys to Starknet. And by these fifth sessions, we're going to be doing advanced stuffs already. That is building advanced smart contracts with Cairo. So I'm sure everyone has been following up, and then you've been having a great time in the course of the boot camp. So my name is Manuel Luca, like you all know. And then today we are going to be building advanced Starknet smart contracts by the end of the day. So a little about me. And then this is today's agenda, knowing what components are. So I'm sure that you guys have already written smart contract on the last session, right? So let me get replies from you guys. Emojis if you have written smart contracts. If you've not, write it in the chat so I will know. That's not supposed to be possible because that's what last session is all about. Today's session is going to be advanced of writing the contract. So if you have not written a single smart contract, then or more, there is a problem. So what did you guys did in the last class? Yeah, guys, you can just write it down in the chat so that we know. What did you guys cover in the last class?
So in the last class, we basically we treated smart contracts and some installations on some Cairo and Rust installation. Yeah, but we did not write deep smart contracts.
But you guys wrote a smart contract now.
Yeah.
Yeah, perfect. That's what's important. All right, so today's session is going to be about components. So we're going to be understanding what components are, properties of a component, a Cairo component, check out the syntax to write a component, and then probably write a smart contract using components before we get to the conclusion or to the end of today. So that's what we should be doing before the end of today's class. So components are like a very interesting part of Cairo, and I think it's one of the things that made the language stand out. So components help us to write codes in modules and then import them or use them within our smart contracts. Components are like smart contracts. They behave exactly the same, have the same properties. Just the difference is that components cannot be deployed. But instead, components can just be used as modules inside of a smart contract. So take, for example, you want to write modular smart contracts, you write them using components. That's what component does. So let's just go to the real thing to avoid confusions. All right, so what are components? So a component is a separate module that can contain storage, events, and functions. And you will agree with me that all these are properties of the smart contract, right? Smart contract contains storage, events, and also functions. So unlike a contract, a component cannot be declared or deployed, like I said. Its logic would be eventually part of the contract bytecode it has been embedded in. So what we do is you write your smart contract, and then probably you can write it in component base, and then you write your smart contract, like let's say in little chunks, and then you embed those components or those smaller modules into your main smart contract. And with that, you are going to have access to all the storage, the events, the functions of that particular component. And it's going to be part of the contract bytecode. So it's going to exist in the smart contract like you wrote it, like it was part of it. So you can use components that was written by someone, or you can choose to write components by your own self. So take, for example, there's a particular module you want to embed into your smart contract, and then you don't have to write it from scratch, meaning there's someone has already written that module, you can be able to just import it into your application or embed it into your contracts and make use of it. And then with that, you have access to the storage of that component, have access to all the events, have access to all the functions, and then the logic is going to exist in your contract by its code, like you wrote it. All right, so think of components as Lego blocks. You guys, everyone know Lego here, right? Everyone must have played Legos when we're babies. So Legos are just those small modular games where you have a bunch of blocks, like couple them together, either to build a house, to build a car, to build a castle, etc. Right? So that's just what Lego blocks are. So look at components like those different Lego blocks. You know, those blocks now, you can have like plenty of them. You can then decide what you want to build with those particular Legos. So take, for example, you have a bunch of them. You can choose to build a castle. And then after you build a castle, with that same Lego, you can choose to dismantle it and then build a very small hut, or probably build a car or something with it, right? So those small blocks are regarded as modules, and then they can also be regarded as components. So each of those single Lego blocks you made use of can be regarded as your components, and then you joining it together to build a castle. Let's look at the castle now, like your smart contract. Yeah. So they allow you to enrich your contract by plugging in a module that you or someone else wrote, right? So this module can be a simple one, like an ownership component. For those of you that have worked with Open Zeppelin or try to implement their ownable contracts, modules are like simple example of what can be regarded as components. Or it can be like a full-fledged complex, something as complex as an ERC20 token. So you can have an ERC20 token as a separate component. Let's say your smart contract is going to be implementing a token that you are going to be creating. So you can choose to create that token as a particular component and then plug it into your application, or sorry, plug it into your smart contract. So you write the logic for the ERC20 somewhere where you have the transfer from everything. You write all those logic, and then you then expose it as a component. I'll teach you guys how to define a component and how to differentiate between a component and a smart contract. So when you're writing a component, you know that this is a component, and then you plug it into your contract, and then you have access to all those ERC20 functions that you wrote separately within those components. So with that, it's very easy for you to do your plug and play or to do your Lego block building for your smart contract. To take, for example, you no longer need the ERC20 component within your contract. On a traditional sense, or previously, instead of you to have to go and delete the whole code that you wrote for the ERC20, all you just have to do is remove that particular component from your contract, and then it ceases to exist. Or if you want to make use of it, you plug it back into your component, and then, sorry, you plug the component back into your smart contract, and then all the functions and everything is back just like magic. Yeah. So basically, that's just what components are. And it's like a new concept for most of you coming from like different programming language, because not every programming language supports this, but Cairo does. I think Cairo is like, yeah, I think of all programming languages I've written, Cairo is like the only one that does like components. Safe to say that. So it might be new, but trust me, gradually, if you understand how they work, you will completely love it. And then you will start writing your smart contracts in modular ways with the help of components. All right, so properties of a component. So what are entailed in a component? Like I said, a component is very similar to a contract, meaning it can contain storage variables. It can have events. You can also have external and internal functions all within a component. And then unlike a contract, a component cannot be deployed on its own. Like I said, it's just a module that you can be able to plug into your contract and then you deploy your contract. So if you deploy your contract, all the functions contained in that module are going to be part of your contract by code. So the component code becomes part of the contract it is embedded to, just exactly what I just explained. So if you have a contract that you are writing and then you have a separate component somewhere, like I said about the ERC20, let's say you have an ERC20 component and then you embed it into your smart contract that you are writing. Let's say it's a swap contract. So if you embed it into that component, automatically all the functions that are contained inside of that particular ERC20 component are going to be in your swap contract. Yeah, and then thus your swap contract is going to inherit all those other stuffs now that the component has, like the storage, the events, and then the functions contained inside of it. So let's proceed. So now let's just head over and look at the syntax, how to write components, etc. So before developing any components, there are a few things to note about the syntax. So first of all, you need to define each component in its own module, denoted by Starknet component attributes. So you guys already know what attributes are, right? I'm sure like the previous mentors must have done justice to what attributes are. Yeah, so this is a simple example of an attribute. This, I'm sure you must have come across it, or this one. So every single component must be denoted by this attribute, so that the compiler knows that, hey, this is a component that I'm working with, right? Perfect. So let's proceed. So next, you define the component interface. So this, you define all the function signatures that you're allowing external access to the component logic. So in this case, just like a normal smart contract, you know, when you're writing your contract, you define your interface, your traits, you define your traits, which can be used to access the functions, the external functions of this particular smart contract, or the functions available for people to access publicly, right? In this case, this component we are trying to build is an ERC20 component, and then all the functions that we want to expose as external functions for people to interact with are these functions that we define within these traits. That is total supply, balance of, allowance, etc. All of this. So we define the traits for the particular component. So our ERC20 component now is going to be implementing these traits. So next, we are going to implement the external logic in an implementation block marked as embeddable as. Good. So this is another most important place again that you guys need to know. So this is another attribute. So these attributes help us to mark the particular name that we want to give our component, so that when we embed it into another smart contract, we know how to access its functions, or the name that we give to it that we can use to access whatsoever thing we want from it, maybe storage variables or etc. So in this case now, this is embeddable as ERC20 implementation. So that's this particular thing right here. This can be changed, so it can be anything. So you can make it, I can write embeddable as manual. So anytime I am implementing or embedding this into any of my smart contracts, I'm going to access it as manual. But in this case, it is embeddable as ERC20 implementation. So this is the name that we know it for anywhere we want to find it. Once we embed it into our system, we use this name to find it, right? And then all this long grammar that we get on. So This is the name that we'll be using in the contract to refer to the component, exactly what I explained. All right. So we can also choose to define internal logic. So this is for external logic, right? That is logic that people can be able to access external functions. For internal, we can be able to define with the internal logic through functions that won't be accessible externally by omitting the embeddable ask block. So for we emit this one, I'm sure you guys have already made use of this guy already. That is this trait. So this generative trait is used for internal functions. This is just for the compiler to know that, hey, this particular function, this particular implementation, you are going to be internal functions, meaning only functions that can be called within the smart contract or what else? I remember. All right. So this is just the short slide I have for you guys. So we are going to go into the normal, what's it called, the hands-on session to try out a few stuff. Try out to build a simple smart contract and then use components within it. But before then, before I go, before we proceed to the next stage, let me take your questions. If there's any confusion so far about components, I am very much available to explain again before we head over to the technical parts. So let's take questions, guys. If there's none, trust me, just give me your emojis and I'll proceed. I'm sure that everyone is okay. So you guys have done like the necessary installations, right? What did you guys use in spinning up your development environment for Cairo? What are some of the tools that you guys work with? Are you guys working with SM Forge for now?
I think most for now we're just using Scarp. I don't know.
Okay, you guys are working with Scalp.
Yeah.
Okay. That works. But me, I'm using Starknet Foundry for now. Yeah, I'm using Starknet Foundry for all my development purposes. That is spinning up a new projects, etc. And then you guys haven't worked with SM Forge, so how do we do it now? So it's the same. Those of you that have done Foundry before, this time around, this is Starknet Foundry. All right. So first and foremost, I want to initialize a new project. So I'm going to make use of this command, smforge init, and then I'm going to type in the project name. So this time around, let's say advanced Cairo. Let's write block fields. So we remember easily. And then we initialize the project. Yep. So currently this is initialized. So let me just open this up and we are good to go. So where's the name? What is happening? I'm coming, guys. Let me just open this up. All right, great. So as soon as we spin this up with SNForge, we get like all the necessary things we need. Like the source folder, the test folder, the scarp.log, the scarp.toml, the snfoundry.toml file also. All this to help us with configuration and also writing our code. All right, so head over here and then get to the leave and get started. All right, so this is just a simple smart contract. I'm sure you guys have written something like this before, right? Perfect. So what I'm just going to do now, I'm going to like take this out and then be sure we are good. So let me just clear that. And then we're going to create like a new file. Let's call this, I don't know what contract you are going to write today, to be honest, so that will make it modable. Should we do the swap? No, the swap would be a bad idea. So what should we build? All right. Okay, let's do something simple. I'm coming, guys. Let me just quickly ask an AI to tell us what to build. All right, so let's just do something simple, like a simple calculator that does an increment and decrement of a component state. And then we are also going to implement a user component or a player component to that particular calculator. So with that, easily, we are going to build the player as a different component, and then we are going to embed it into one particular smart contract. And then we have access to all the functions from there. So you guys see how it works out. So that's basically what we are going to build it. All right, guys. So here, right now, let's create the file. Maybe let's say this is a calculator. Let's call it calculator.doc, where we are going to be writing like our smart contracts and then other stuff. All right. So first and foremost, let's implement what we want here. Implement the traits. How many functions we have within this smart contract. So this is the main smart contract. So let's do like the normal entry. Starknet, let's slide the attributes. Sure. So this attribute is to verify that this is a contract. Interesting. So Copilot have already written down the whole of this stuff for me. So how do we do it? Let's just take it gradual. Let's just do this ourselves. So let me just make this public mode and then call it calculator, like how it was suggested. So forget about this contract state. First and foremost, we are importing the storage. So like every single smart contract, the first thing that must be implemented is storage, right? Even though in Cairo, it is very important to have it. even though you don't want to have any state variable inside of it or any storage variables, you just leave it empty, right? So let's create this now. Let's say storage. This, I'm trying as much not to use this guy, but they already have it. So what am I to do now? So storage is normally a struct, right? And then a struct with the name storage, right? Perfect. And then this thing is a blessing, but not to teach, to be honest. If I was coding on my own, then this would have been more sweeter. But now it's giving me suggestions, and I hate to see suggestions at this point. So what do we call this? This is yeah. So now we already have the storage. This is like a simple smart contract. We already have the storage implemented. And then the storage have only one state variable, which is like a felt 252, right? And then now we can go ahead to add events if you want to have any. But in this case, I don't think it's necessary to have anything like an event. So I will not be stressing to do that. And then next, I'm going to write the implementation. And then I don't want this implementation to be an external. I will just use the normal ABI attribute so that it knows that it is going to generate an ABI for the implementation of all the functions that are going to be here. So all I just have to do is add this attributes, ABI, then embed underscore vnotes. And then I'm going to write the implementation now. So before I write the implementation, let's declare the traits, right? So let's start from the traits first, which is very important. So to implement this trait, I am going to call this attribute so that it's going to know that this is a trait. This time around, I use Starknet interface. So let me just copy this guy, paste it here, and then change the contract to interface. So these are going to be the interface of that are going to be implemented inside of the smart contract. And then already it has done it for me again. So I use the traits. It's a public trait, and then I can start with the I. Just this is not like compulsory for you to start with I, but it's just the convention so that I know that this is an interface, right? Just like how we do it in Solidity, guys. So I can just say I calculator to know that this is the interface of the calculator. And then next up, I am going to add this generic. I'm sure you guys have worked with generics, right? So generics mostly are like placeholders. So in this case, the trait we are writing is going to be implementing the state of this particular smart contract, of this calculator contract. But in this case, when I'm implementing when I'm writing the trait, I am going to put a generic here to serve as the state. So let's just call it, mostly everybody use T contract states. You can use T state, any word you want to make use of there. You can also use to write, you can choose to write only T safe. But me, I like to make use of like T contract states. And then I'm going to add in the functions now. So these are the functions. And then this copilot, if you guys notice, it is all the hints is giving me is Rust. right? So you have to be very, very sure of what you are doing. Instead of writing Cairo, don't end up writing Ross, right? So I can add the first function. Maybe let's say we have an add function. These are the functions I'm going to be implementing. I'll just use the add and subtract in this case. So in Cairo, this is going to be a state mutating function, right? So you say ref, I'm going to call, yeah, so it has done it for me already. So I just click on tab and I'm good to go. So this is the explanation. First and foremost, the first parameter must always be like the state that we are going to be working with. In this case, we put the generic. And then this ref self, it is trying to say, okay, the ref is, this is a state changing function. So it is referencing self. And then these are the two parameters we need, A and B, to get this result back, right? And then finally, the subtract. So this is the last thing I'm going to do. I will just be implementing only the add and the subtract functions here. All right. So successfully, we have created the traits for this particular smart contract that we are going to be working with. Next is for us to implement the trait within the contract. So that's what we want to be doing here. So these are the external functions. And then I'm using this ABI to annotate them. So with this, automatically it knows that since I'm using ABI embedded VNOT, automatically means all the functions here are external functions. And then the compiler should generate an ABI and all the necessary things it needs at the end of the day, right? So now let's write this implementation. So to write the implementation for this trait, all I just have to do is write impl keyword, and then write what I'm implementing. So in this case, I'm going to be this is the calculator implementation, and then of what now? So this is the implementation of I, then I call this calculator. So I calculator traits, which is the interface of the functions we are implementing, right? I calculator. And then next, I am going to insert the real state I'm going to be working with. So in this case, I'm going to be working. Before I was working with T contract state, which is just a generic. But this time around, I'm working with the main contract state, which is this storage that we have over here. So any mutation we are going to be doing is regarding that storage. So I write this down, contract state. Yep, and I'm good to go. All these suggestions are they're annoying, to be honest. All right, so let's just try to fix this up. So now I have to write all the implementation of this particular function here. But before we go further, let's be sure you guys are seeing green everywhere, right? It's because most of the things are not compiling yet. So let's try to let's import calculator into the lib folder so that everything is going to be compiling by our language server. So let's make this public mode, and then I call calculator. Perfect. So this knows about this, and then any errors we can be able to easily. So currently now I'm getting this error, which is highlighting this trait for me, telling me I calculator not found. And that's simply because I haven't imported it, right? So remember, these two are different. What do you guys call it? There are two different scopes. So take, for example, this interface is implemented here. So for me to use it here, I have to bring this interface into scope here. So let me just do that. So to work with that, I just work with use. So I will use super, and then super can bring everything I have in here for me. So I will just work with iCalculator. So iCalculator, and I close this, and then it knows what to work with. And then why am I getting an error here too? So the error here says not all traits are implemented, simply because I haven't implemented all the functions here. You know, I'm saying that this implementation of calculator impli of iCalculator contract state. So this implementation is for this particular trait. So I can choose to write another implementation again. I'm sure the last mentor have taught you guys all this. So if I don't write all the implementation here, this error is not going to go until when I've written all the implementation. So let's not worry about it for now. So back here, I write the function. So let me write the main implementation now, add. And then this particular function is a state mutating function that I'm using ref self. And then the real state I want to be mutating, which is contract state, right? I'm sure you guys, are you guys following me? So the two words we are going to be adding is A, which is field 252, and B, which is another field 252. And then at the end of the day, we want this function to return a field 252. Yeah. So close this. And then we write the implementation. So let's work with what they have, but we just have to be tweaking it. If not, it's Rust that is mostly written here. So we do let, we can say underscore results. So it's equals to A plus B. So what's going to happen is that after every permutation or after every changes, we just update the result to this particular state. That's just what we are going to be working with. So next is for me to mutate the state now. So to do that, I use self dot, and then I call the particular state variable I want to change. As you can see now, they are trying to access storage, and then they access result, and then they write. But we don't need to do all those. All we just have to do is say self dot result dot write, right? That's already completed it for us, and then just tab, right? Underscore results. And then at the end of the day, it should return results. So with this, we are good to go. We have written the first function. So what is happening in this add function is that the add function, we are collecting two variables, A and B, adding them together, and then whatsoever the result is, we write it to the state, and then we update this. Likewise, subtract. So let's just do the same thing here. And then our error is gone, so no need of wasting of time. So next now, I will just try to build this. Then we are going to try to write the components, then implement it inside. So let me get my terminal. So to be sure everything is working, let's run SNForge is build, or work with the normal guy we know, scarp build, right? That you guys know. All of them will work the same. For SNForge, is using scarp behind the scene. So if everything goes well, we should get finished. Yeah, so perfect. Everything is correct. We got compiled within 4 seconds, and that simply means this particular contract is okay and good to go. So next up, let's create a component and then embed the component into this particular smart contract that we are writing. All right, so what will just happen is I'll create a new folder here. I'll call it components. So take, for example, I want to be having plenty components within my smart contract. I can just work with this guy. And then the first component I want to be working with is user. So the user is who is going to be using this particular smart contract, right? So let me just say user.cairo, and then I'll write the components for the user. So on a norm, I can write all the functions I need for a user, maybe the functions to register a user, the functions to sign up a user, etc., all within the calculator contract. But then I want to make my code modular. That is why I'm doing it in another different component, so that easily, take for example, now I just want to work with the peer calculator. So let's say, for example, this calculator is already working, right? I don't need a user. I can work with this peer minimum like this, right? But then if I want to implement like a user, maybe I want to track who is calling the add function, who is calling the subtract function, who changed the state last, etc. I want to do all those stuff, right? I can choose to write a particular component, in this case, which is the user component, and then register all those things I need to register, then import, then embed it into this calculator contract, and then I'm going to have access to all the functions that are there. And then anytime I'm tired and I feel, hey, I don't need I don't need to know who is calling this function. I don't need to know who is changing the state. I don't want to implement the user component again. All I just have to do is, instead of me removing everything from my implementation, going to remove it from interface, all I just have to do is just take out that particular component, and all the functions there are going to be out. Yeah, so that's what we're working with for now. All right. So user components. So like we said, components are the same with smart contract, nothing different, exactly the same thing that we are doing. They have their own traits, they have their own storage, they have their own event, etc. Anything you want to implement in a particular component, they all have it, right? So let's head over to writing this now. So first and foremost, I want to write the interface for the user component. So all I just want to do for now is I want to register a user before a user is going to be able to use my calculator, right? So I don't like writing these things down, to be honest. Let me just do the copy and paste method I'm used to. Oh. So this time around, I'm working for user, right? So I'll just say I user traits. But like, I don't even put the traits. It doesn't have me there. So it has already implemented everything for me. The T contract state, but I don't want to work with this function. Okay, let's just work with this, the get name and set name. So what will happen is, with this, you can get name. So I don't have to use ref here. I just only need to take like a snapshot of the state, since this is a read function. And then I have a function here that can be able to set a name for a user, and a function that can be able to get it back. Yeah, so let's get to it. So next up, write this one. So this is, but this time around, remember, we're not writing a contract, right? We are writing a component. So this time around, the name is not going to be contract, or the, what do you guys call this thing? The attribute is not going to be contract. The attribute is going to be component. That's just the basic difference between the two of them. Yes. And then this time around, I want to call it the user components. Let's get to it. So let me import. So it's already giving me suggestions. So let me import the traits, which is I user. as the particular trait. Well, this thing don't write everything for me. I'm sure you guys understand what's happening here, right? So let me not deceive the AI because I'm the one that set it up. So this is the same thing like your normal smart contract. If I go back to this calculator, you see we have an interface here, a trait that contains the two functions we want to be calling inside of the trait, add and subtract. This is our contract. Our contract has this implementation for calculator implementation, right? And then it has add and subtract inside of it. This is the storage, we can mutate, etc. So next up, the difference between these two, notice this guy here, calculator, is a contract because it's denoted by this attribute, contract attribute. But this user is denoted by the component attribute to show you that, hey, this guy is a component. Yeah. And then the next thing now we need to do is we need to make some few changes here. I think, let me just clean this guy so that it doesn't confuse us. And then we have the storage. So the same thing, this guy also has his own storage. But what is going to be different here is we are not going to be declaring all this implementation with an ABI. What we are going to be working with is the embeddable as attribute, like I told you guys. And the embeddable as attribute is what we are going to be using as the name of that particular as the name of the particular component, so that within our smart contract we can be able to reference it or make use of it. So all I just have to do is say embeddable as. How do you spell this embeddable? Yep, I think this should be it. Embeddable as. Then the name. What am I embedding it as? Let's say user. So we call it user anywhere we see it. Let me do user with a capital letter. All right. And then we head over to write it like a normal implementation too. But this time around, some things are going to change, right? So this time around, this is the user implementation. What? This is the user implementation, and then we have to like insert some few things here. First and foremost, the contract state, so that it knows the state we are working with. So this time around, let me use C contract states tab, and then I'm going to add this has components. So you have to add that so that it's going to know that, hey, this guy is a component, right? And also we are also going to add the state inside of the has component. Contract states. Yep. Yeah, so I guess you are good. So these are the first things you need to put. Then you add the off keyword. Then you tell it the particular trait we are writing all this implementation for. And then this time around, we are writing it for iUser. And then we are embedding this guy, not direct as the contract state, but we are going to be adding component states there so that it knows that this, what we are working with, is a component. Now you need to do all these things here so that within the contract, it's going to help us easily access the storage of the particular component or the event, etc. Right? If not, it is just going to get confused, because if we import it now into our contract and then we continue using contract state, it will think it's our normal contract state that we are working with, and then it will end up mutating another different state for us. But this time around, we are working with the state of the particular component. So that's just what we are doing here. So let's add it. component state. And then add the T contract state inside of it. So I think it has done that for us. This guy is doing more than enough help for me. Yeah. So I think like the main thing has already been done. Copilot have already done it for me, so I don't need to stress. So what's already happening here is we have written the implementation of this, and then we embedded it as user. So anywhere we can be able to access this guy as user, right? And then have access to all the function. Get name function has been written down. We are taking a snapshot of the state using the component state, and then we are getting the name of the particular user. And then next, we are setting name also. So let me just add like a few stuff to this guy. So instead of making this name, let me just make this let me make this a map. So I think I'm supposed to import map also. Let me bring all those importations here. I want to make it a map, and then it's going to be a map of a contract address, which I've not imported yet, to 252. So that's what we are going to be working with. So let me try to import the map here. I can get map from storage. So I just use Starknet storage. So it has imported everything for me. I love this thing, man. It's giving me joy. Yeah. So moment of truth. Now let's try to do a few stuffs here. If we get an error, then we know it's not working. So let's say components. So I have to create a file here so I can be able to have access, and our app can be able to read it. Public mode calculator. No, not calculator. User. Is user. Yeah, it should be. Are we getting errors here? Nope. Why? And then let's try to, yeah, I think after this we should know if it's working or not. So the components, good. So it's already ready. So here are all our errors. And then contract address is not getting from storage. That's why we get contract address directly from I don't tire for this thing. It doesn't make sense to teach with this, to be honest. It's annoying. Yep, so let's try to get contract address. I think we can just get contract address from Starknet direct. So there are better ways you can do this. Why is it not finding it? Yep. So the component states are the rest. Do I also need to import all those guys? Why am I getting error? All right. So what's the error here? So parameter type of implementation function user get name is incompatible with our user get name. Expected T contract state, uh, and then the actual is a snapshot of T contract state. Okay, I get you. All right. So to be on the safer side, let's just head over to the Cairo book so that it's going to help us out. Easy, easy peasy. Mm. So let me just get it open. I'm hot. All right. So let's have a look. So creating components, right? To create components, first define it in its own module created by this. We have already explained all these things. The attribute within the module, you can declare a storage, struct, event, enum as usually done in contract. The next step is to define the component interface. We have already done this, that will allow external access to the component's logic. You can define the interface by the components, declaring the traits. This interface will be used to enable external access to the component function using the dispatcher pattern. I'm sure you guys know the dispatcher pattern, else I can explain. So the actual implementation of the component's external logic is done in this implementation block marked by embeddable as with this name. And I explain why we need it, right? So all the external functions of that particular component, we know that we can use the name that we embedded as to be able to access it. So note, name is the name that you will be using in the contract to refer to the component. Accept this. You can also define internal functions. I think we've done this one. Good. So this is where we are now. So functions within this implementation blocks expect arguments like ref, self, component state, T contract state for state modifying function, or self at component state, T contract state for view functions. This makes the implementation generic over T contract state, allowing us to use this. Yeah, so let's look at a better way that they did it. So this is an example of a read function. We declare it this way. So let's see whether we are doing the same thing. Oh, where are we? Where are we? Okay, so this is one of our errors. We're supposed to take snapshots of these states. So we take this guy out also. And then take snapshots of the component states like it's written. Yeah. So we're gradually solving the errors. Yeah, and then for the right function, we use this. So I guess with what we have here, we are correct and we are good to go. So the only problem might be we not calling this particular storage functions or methods. That's why we are getting an error with reading and writing. So let's try to highlight and see. So wrong number of arguments expected to, okay, I've seen the problem. So, we changed this to be a map, right? So in this case, it's expecting 2 arguments from us. It's expecting 2 or just 1 inside of it. So the first, why it's telling you 2 arguments is because the first argument is like the contract state, which you already have inside of it, right? So the next argument is the parameter I want to use to get or read from that state. So in this case, we need a contract address. Let's say caller. So whosoever called this, we are going to get his name. So to get caller, we say let caller equals to get underscore caller address tab, right? This is not imported yet. Where do I get this one from? Is it from here? Let's try. Yeah, get caller address, and we are good to go. So you read the passing caller, you are going to get the name back. And likewise here, if you want to write to the states, all we just have to do is what we are writing and then the name. So this time around, let's get caller again, who is the caller of the function. So let's say let caller equals to done this, and then okay, no need to even pass in the name. Okay, we need the name actually. I thought it was a read write function, so clear this one out. No need, it's not a 2D function, and we are good to go. So this component is fully ready. And then, sorry guys, let me just make a few tweaks here. So this caller should be passed into the function. Take this guy out and just put underscore caller here. And then this is going to give us an issue. Let's just copy this guy and add it inside of the traits. So to get name, we pass in the contract address to get the name. And then contract address is not found. So let's import it. So we say use Starknet contract address. Yep, and we are good to go. Yeah, so fingers crossed, this is it. We don't have any errors. Everything is working fine. We're having a good day at work. But we are still expecting errors. So how is it so far? Hope you guys are understanding what's happening. Or everyone is lost. Okay. So here now, we have successfully built a component. We have successfully written a calculator contract. And we have successfully built a component, a user component. So what we want to do now is that we want to import this user component into the calculator contract and then make use of it. And then this component is a component that we've written on our own. We wrote this code ourselves, right? So in most cases, why you make use of components because you don't want to write the code yourself. Probably I've written the code for user. And then you too now, you feel, I implement this user functionality into my application, but I don't want to write the code. What do you need to do? You just need to go to my GitHub, get my GitHub link, and then do all the importations, and you get it through your scarp.toml, and then you can import it as a component within your app without you even writing the code. So I think that should be the last thing we should try out. After writing components ourselves, let's try to use an external component that someone else has written and bring it into the application. So let's do the necessary importations and or the embedding. That's like the best word to use. Embed. So how do we embed this now into our contracts? I'm sure I've gotten this here. So let me just head over to calculator. Yeah. So this is where we want to embed this contract, right? Or this particular component that we've written inside of the calculator contract. That's where we want to embed it. So what are the first things to do? So first and foremost, we need to import the components that we just put down. So let's import all the necessary logic inside of it, right? So all we just have to do now is say use. So to import it, since we are the ones that wrote it ourselves, use, and then let me refer to scap.toml, advanced Cairo. That is the name of this particular project. With that, we can be able to access anything we need. Yeah, so as you can see, we have components here. Then which of the components now? We want to work with the user component, right? That is the component that we are trying to import or implement here. So next we bring it in and then we say user. Then lastly, we call the function. Yeah, it's a user. It's a user we wrote it as. Yeah, it should be. No need of bringing the implementation. This is, we are good to go. Yep. So the next thing now is to import the necessary guides we need. I've already brought the components here. So next up now, let's bring the storage of this particular component here. So to bring the storage, we have to work with another attribute, which is the sub storage attribute, to verify that, hey, this is also a storage that we're embedding inside of this storage. But this storage belongs to a different component. But this time around, we want to plug in this particular storage, the storage of this component into our storage of our smart contract. So that's what we want to do now. So we make use of these attributes. Let me just write it down. Option sub storage. Sub storage. This is how this spells storage, and then v not. What's happening? Okay, I think this is plenty. That's why. Okay, so next up, let's bring this in. What we are working with, which is like the user storage. So what's going to happen now? We call this user storage, and then we call it in. So to get user storage, first and foremost, we have to access it from user, which is the global thing that we imported here, right? That particular user, and then we call the storage. I think this guy has already auto-completed it for us, so there'll be no need for us to do that. So automatically now we already have the storage of storage inside of the storage of our calculator contract. So gradually we are importing all the necessary things we need. If we also had an event, we can also import the event into our event. But in both the component and the smart contract, we don't have any event. So there'll be no need to do any of such. So next up, we are going to call the component keyword, and then use the keyword to run the necessary permutations we need. So let's say components. Components, and then the necessary things we need. So in this case, we need the path to the component, which is like number one. So the path in this case is what we have imported, which is user. So I brought user there. No need of doing any extra stuff again. And then next up, the storage of this particular component, which already we have already brought it in again too. So no need of that. All I just have to do is call user storage here. As I wrote it down here, that's the same way I'm going. And then lastly, we need the events. So I think we might have a problem here because I don't have any single events for this at all. So what do they want me to do? I should create an event or what? Yeah, so that would be a problem. So maybe we can just create an event and just bring it in. So next, now let's create our events inside of this contract so that we can be able to bring the other events in. So to create events, you all know how to do it. Let's use the event attributes, right? To verify that this particular struct that we are creating or this enum we are creating is an event, right? So let's use public enum and then call it events, right? So now we don't have any event created. I just want to bring the regular events in, or the event for user components. That's the only thing I want to bring in. So let me implement another attribute, which is a derive and also the Starknet event attribute, which is most needed. So we can drop and then Starknet events. Perfect. So we are good to go. So next now we create an event. Let's create an event inside of this component. Oh, where is it? So no stress. Let me just do this here. Let me copy this thing I just did here and then import it back. I won't write a single event inside of it. Yeah, so this would be it. And then let's make the event empty, then back to calculator. Now let's import this particular event inside of it. So to work with this, just like the sub storage, to specify that this storage belongs to a component, we are also going to flatten the event to specify that this particular event is for a component. So let's use the attribute flat. So you guys can go deep and understand what all of this attribute does. I can send you a link to it, and then you guys can look it up. I think it's normally in the SCAP documentation also. All right, so the name of this event is user event. Let's call it user event. And then we can get it from user events. So we are good. So next up now, let's bring it here and say user events. Fingers crossed, our errors should go by now. So what's the problem? Let's highlight this guy and see. So invalid component macro, expected component name, that is the storage. Yeah, that's what I gave you. Okay, so let's just go back to the book. I think anytime we are there, we get our answers easily, right? Yeah, this is a component embeddable as enable the generative traits. Yep, this is where we are now. We have done this component, written the parts, enable components, storage, enable event, enable event. Just exactly how we did it here. This is enable, and then the event also. Enable component event. Good to go. So what's happening? Let's try to troubleshoot it. I'm coming. Let me switch where I place this. Maybe that might be the problem, which I'm not sure. These are storage. These are well imported already. So what's the case? Back to this guy. First, component, enable component. And this is it from component, enable component, right? Good. Storage from enable event. That's enable component storage, enable component event. That's same thing we did, man. So what is the drama now? Or let's try to check the states variables and also of the components. That can help out. All right, we already have a storage here now. So this event, I've been at the event one give us issue. No need. Now let me try to check this importation. All our train errors. Okay, same name. Oh, okay, okay. Yeah, that was our problem. We're writing it instead of curly braces instead of the normal braces. So that was the issue. So successfully now we have imported our components in here and then everything is working. The part is user, the storage. We have imported user storage here and also user events, right? Yeah, so okay. So we are good to go. Now, the last thing now we are supposed to do is to um, expose the implementation so that this particular contract can have access to it. So already here we have inserted the component here. Next is to do what I just mentioned. So let's go back to the book and then check it out. So I've done this, guys. So the components logic is now seamlessly part of the contract. We can interact with the components function externally by calling them with the IONable dispatcher. I think I've gone faster than my shadow. Yeah, so this is it. After we have done all this component implementation, next is to expose the implementation. Like what they did here. You see, like the ownable component here has already been created. So they just declared it here with the component macro just to like embed it into the code. You know what macros does, like they spin up, like for those of you that have done Rust, you understand what macro do. So what's happening is that it helps you get like code logic in real time. So with this component macro now, it's going to help us have access to all of this code. So next now is just to bring out the implementation. So our implementation in this case is this guy. So let me just do it back here. So we'll just do it here, right? So let's say let's user implementation be equals to, I think they've done this already for us. Uh, or back here, let's not follow them because these guys now Rust, they right. So we have brought enable component and then we bring the particular implementation we want to work with. So in simple terms, this is the explanation. We have already written the user component here, right? So the implementation we want to be bringing in this case is this one, which is user implementation. And then if you guys have worked with implementations before, trait and dispatchers, you understand that you can be able to write like multiple implementations inside of a particular contract or inside of a particular component. and determine which of the implementations you want to work with. Like if, for example, I can have user implementation here, I can have user 2 implementation, and then choose to work with only user 2 implementation here, right? So that's the same thing that is happening here in this place. They had 2 implementation. First is the external implementation, which is only this, and that's why they are annotating it with this guy, ABI, so that it's going to embed and generate, and they know that this is an external function, generate it as part of the ABI, etc. And then for the generative script, you don't have to do any annotation to it. So this is the example. So if you go back to their own able, you see that they had like over like 2 different contracts they were working with, 2 different implementations they were working with. So next up, let's bring up the implementation, but then we are going to work with this one. So let me just copy this guy because we want ours to be part of the ABI. And then let's call the implementation now, which is user or user implementation. And then all I just have to do now is to add the contract state so that now it knows that it's our contract state that it is working with. Do I need to add as component? No. Let me confirm that from here. And then no need of let. We just write the implementation direct. Why we're still getting problems. Crate not found within this calculator. Why? It says you can't find the traits, which is advanced Cairo component user implementation is not visible in this context. Why is it not visible? Is it that we didn't make it public or what? That might not be the problem. So let's try to troubleshoot. Those of you that have tried it out, or has anybody done components here? I don't think so. Why is it not visible in this context? I'm coming, guys. So does the implementation have to be public? Because we have eventually come to the end of this. But then this last problem wants to keep us ransom. Oh, oh. Guys, who can guess what the problem is? I just fixed it. So can someone guess what the problem is? And then that would be a perfect way to end the class. To be sure someone was following me. Can anyone try? All right, so let me just clear that out. So what happened here was that remember when we're creating the component, I told you guys when you make it embeddable as the particular name you give it is what you are going to be using to access the particular functions and method of that particular component, right? Perfect. So that's what happened here. So inside of here, to be able to access it, I had to use this particular name that we gave it, which is user. So to be sure this is working, let's just try to build, and if the build goes successfully, I don't think we can deploy this contract. We can, but did you guys deploy a contract from the last class? So maybe we can just deploy it to be sure that everything works correctly, so that you guys will see all the implementations that's to be sure that this works. So let's run scap build. If this build, then let's try to deploy it. And then I'll just send you guys the contract address, then we'll view it to be sure everything works correctly. Yeah. So let's try to deploy our contracts now. So sorry, I don't need to write down this code. Let me just go and copy it. So let me declare the contracts and then deploy it. So you guys already know the method to work with. I'm working with Starknet Foundry. And then to do the declaration, I have to work with SMcast. I already have an account set up, which is an OpenZeppelin account. The name is Emperor. And then in Cairo, like I told you guys in the first class, you have to declare before you can be able to deploy a contract. So that's what we are doing now. We're declaring, and then this time around, we are going to be working with Sepolia. That's why our RPC URL is this. The fee token is ETH, and then to deploy this, I have to put the contract name I want to work with, which in this case is calculator. So let's declare this. Fingers crossed, this should work out. Perfect. So that's declared. So next, let's try to deploy it. I will also copy the code and bring it in. All these are very easy things. You can just check out the documentation, understand how they work. So to declare it, I do the same thing, but this time around, I'm going to pass in the class hash, which is what was declared here. And then with this, I can be able to have a deployed version of my contract. Perfect. So my contract has been deployed, and then this is it. So let's go to Voyager and check it out. Voyager.online. Yeah, switch to Sepolia. And then I paste this guy in. All right, so our contract has been deployed. So let's go to the right functions. Oh, what's happening? Okay, so I think we didn't embed the last implementation. That's why we had it this way. So as you can see, this only giving us access to the functions that we wrote inside of this contract. Yeah, but if this works successfully, we should have access to all the functions. That is, we should see get name and set name inside of this particular contract. But I think we haven't embedded it yet. So let's go and copy and paste that, and then we are good to go. So let me just take this one. So the use of this is to tell you that, hey, this whole implementation, embed it into the API so that we are going to work with it. So what will happen now is let me try to declare again. So sorry, guys. I'm declaring this. Okay, let me just copy this code. Let me try to declare again. And then back here, the name is calculator. All right, and then lastly, I have a new class hash. So let me deploy now. So fingers crossed, this should work. This should give us access to all the functions needed. So let me copy this address and then paste it in Voyager to be able to access. All right, so we are good to go, guys. As you guys can see, our components implementation is successful, and you can see the set name function here. And if I also go back to the read contract, you can also see the get name function. And back here, you can see all the previous functions we had, and then the new function we brought from our components. So if I want to take out this particular set name and get name functions or their implementation, all I just have to do is take out their implementation, and then you will not be able to access that function. If I want them back, I put it back in and we are good to go. So this works in different methods. Like take, for example, I for one as a developer, how do I work with components? So I've written so many smart contracts in Cairo, and then I, for one, like making my smart contract upgradable so that it can easily be upgradable. So what I just did is I have a component that is being written down. Mostly what I use is Zeppelin components. And this component can help you upgrade your smart contract. So instead of me always having to come back to write the function to upgrade my smart contract always, or having to make it diamond standard like the Solidity guys work, all I just have to do is a component is written down separate. The work of that component is that it can be able to upgrade my smart.
So if you're speaking, we can't hear you.
Yo, can you hear me now?
Yes.
Perfect. So sorry, my mic went off.
Okay.
So let me come again with that explanation that I was giving. So I said, as a Cairo developer, I've written so many smart contracts, and then most of the times, the most reusable components I work with are.
I think your mic just went off again. We can't hear you.
Yeah. So how about now?
Yeah, yeah.
Perfect. So all the batteries are going dead for. Yeah. So can you guys hear me now?
Yes.
Perfect. So all my microphones were dead. That was why. So I'm
Okay.
using my input mic now. So like I said, as a Cairo developer, I work with components. So most of the smart contracts I've written are upgradable smart contracts. So I can be able to add functionality subsequently to them. And then all I just have to do is I just wrote down one upgradable component that I can be able to use to upgrade any smart contract. So after writing that component, when I write a smart contract, any smart contract I write eventually, all I just have to do is I plug in that upgradable component into the smart contract. And then I'm going to have access to the functions that can be able to help me do or make upgradability within my smart contract. So that's one perfect use case of using components for reusable stuff, or making your contracts or making your smart contracts modular. So now, instead of me writing the logic for the upgradability direct into my contract, I wrote it in a component. And then anytime I want to use it in any contract, I don't have to stress myself to have to write it again. All I just have to do is to bring that component in and then write the implementation, or have access to the implementation within my smart contract. So that's just basically it for Cairo advanced contract with components. Components just help you build modular or modular smart contract, plug out whatsoever you don't want within your smart contract, or help you build your smart contract like Legos, so that you can easily add stuffs, take them out without your code being messy at all. So basically, that's just what components are. And then with this, it's safe to say that we have come to the end of this class. So let's take questions and then we're good to go.
So I think there are a lot of questions, but we need to go through this class again, like through the video, properly
Yeah,
understand. Then maybe we can reach out personally with some questions.
that's perfect. To be honest, I, for one, when I started learning about components, I was completely confused. And then I continued building my smart contract the normal way we have been writing them. So at times, I will even deploy it. Normal way I work with Solidity, right? I'll go and deploy the contract somewhere else and then go and bring it in and then try to use the interface to interact with it, etc. But when I understood how components work, I started doing my things like easier ways. And then I didn't have to rush it. So as a Cairo dev for now, I would say don't rush it. Just continue doing your stuff. And then gradually, when you keep working with these things, you understand how components work better. But just for now, just know that when your question or when you're in search of modular way of doing things, just ASAP go for components. That's just the concept we're trying to explain today. Yeah. So with this, we have come to the end of today's class. Thank you very much, guys, for your time. Keep on studying, keep on learning, and then make sure you learn more and learn with one another in the Starknet ecosystem. So thank you very much, guys, for your time. The Cairo book is your go-to location. My DM is also open, and there are also other guys within the Twitter or within X that can give you profound answers. And also within the Telegram communities or the Telegram chats that you guys are on, you can feel free to ask your questions there.